Hello, this is Malcolm Bowden. I'd like to speak to you on the subject of the retrograde motion of Mars. Some evolutionists claim that this movement, easily explained by heliocentrism, cannot be explained by geocentrists, and that our case therefore collapses. Let us first look at the heliocentrist explanation. Now Mars travels anti-clockwise around the Sun, going slowly right to left against the background stars, as viewed from the Earth. However, as the Earth goes past Mars, Mars appears to suddenly go left to right for a short time, before then returning to the normal right to left motion. Let us look at what is happening. First, the further away from the Sun that a planet is, the slower it circles the Sun. This is because the attraction of the Sun is smaller, and it therefore has to travel slower, so that its smaller centrifugal force is just equal to the smaller attraction of the Sun. If it were faster, it would move further out, and if it was much faster, could leave the planetary system entirely. Similarly, if it slowed down, it would move nearer to the Sun and could even spiral into the Sun if slow enough. In fact, this fairly stable situation of so many planets around the Sun has never been adequately explained by evolutionists, despite several unsuccessful attempts. So the Earth is moving faster than Mars. Now the Earth can come fairly close to Mars, and as it swings past, Mars seems to go left to right for a short time. Let's see why. Here we have the Earth coming closer to Mars, then closer still, then opposite Mars, and it seems to go backwards for a short time against the star background, and then gradually as it passed Mars until it is well past, and Mars continues its slow right to left motion against the star background. Can geocentrists give a series of stages that produce identical results? The answer is a very definite yes. Before we do so, let us first make one point. Although animations show Mars briefly going backwards, you cannot look through a telescope and see all this happening. It is much more like taking a picture each night, and then you notice that in each successive picture Mars briefly seems to go backwards. The pictures would be 24 hours apart. Now, to simplify the complex orbits that we will be dealing with, to start with, I will assume that Mars is stationary and does not circle the Sun. This means that it is fixed in direction from the Sun to the star background. This is the vertical line that is pointing to the star background. As the Earth is stationary, Mars is nearing the Earth. As it swings past, left to right, it is going much faster past the Earth because it is much nearer, say moving past at 3 degrees per night or 24 hours. It is like a train approaching a station, travelling fast past the station and then slowly disappearing into the distance. Let us now look at this from the Earth's point of view. When Mars is passing close to the Earth, it will be travelling left to right quite quickly, say 3 degrees each night. Now let us add in Mars' fairly slow normal orbital speed to this motion. If it is travelling right to left at say 2 degrees per night, then when it is near the Earth, its 3 degrees per night left to right motion will be larger than its 2 degrees orbital speed, and it will briefly travel left to right at 1 degree per night for a short time. So you see, the geocentric model can explain Mars' retrograde motion just as easily as the heliocentric model. What our evolutionary critics have forgotten is that observations of planets, moons, phases, or in this case relative motions, simply cannot decide between the heliocentric model and the geocentric model. I demonstrated this in my video about the orrery. All the relationships remain the same whether the Sun or the Earth is the center of rotation. I hope you found that interesting. Thank you for listening.